Kia ora koutou, welcome back. So I want to talk about the last type of equation that we might end up having to rearrange, where the thing that we're wanting to make the subject of our formula, so we'll say it's x this time, what happens if it ends up that it's actually in two different places? So we look at it and we see that actually we can't easily just get x all by itself. So let's have a look at this example here. I've got y equals x over x plus 2. So at the moment, we've got x as the numerator and x as the denominator all tied up with plus 2. So straight away, you'll see that when we multiply out by x plus 2 on both sides, it's still looking a little bit messy. So the aim of the game with these types of ones is you want to get all your x's together. So just like when you're normally rearranging, you need to get all those x's together on one side. Okay, so get rid of everything else onto the other side. Get all any terms that have x in them, get them all on one side together. Now, how to make sure that you've got terms that all have x in them is you're probably going to need to expand out at some point. So some hints for these particular ones is you're probably going to need to expand, and when you expand out, you'll end up creating a few different little tools. Or what have I done there? You're going to end up creating a few different little terms that each have x in them. Okay, rather than having x tangled up within some brackets or under a square root sign or something like that. And then you're going to later on, once you've got all those terms with x on one side together, you're then going to factorize. Okay, and when you factorize, you'll end up that you can pull x out of each term and then divide by that factor that you've made. Okay, so if we look at this example, let's see what we can do. So, like before, let's get rid of that fraction, okay, because we've got a dirty old fraction here. So let's multiply both sides by the denominator. So let's times both sides by x plus 2. Okay, so we're going to end up on our left-hand side with y times x plus 2, and on our right hand side we end up with just plain old x. Cool. Okay, so again, our x's though are still all over the place, aren't they? They're on both sides of our equation now. One of them's tied up with the brackets, one's not. So now we'll expand out that left hand side. Okay, so we end up with xy plus 2y equals x. This looks a little bit nicer. You've got terms that have x in them and you've got terms that don't have x in them. So get all those terms with x in them together on one side of the equal sign. Get everything else on the other side. They can bugger off to the other side of the equal sign. So I'm going to put my x's on the left hand side. Doesn't actually matter which way around you do it. So I'm going to make it xy minus x. So we'll minus x from both sides. And we'll minus 2y from both sides. Okay. I did two steps at once there, you might notice. If I wanted to do that one step at a time, I'd have xy plus 2y minus x equals 0. And then my next step would be xy minus x equals negative 2y. Okay, if I did them in the two steps. Rightio. So now my left-hand side, they're looking good. Every term that's in there has x in it. The x's aren't tangled up in brackets or square root signs. So now we factorize. Okay, factorize. So I'm just going to rub out this stuff down here. All right, so let's do it. We've got x. He's our common factor. That's exactly what we want. So now we can hopefully see, remember the whole aim of the game is that we want x to be by itself. So let's now divide both sides by y minus 1. Okay, and you've got it. Looks lovely, eh? If you had, instead of putting your x's on the left-hand side, if instead at this step up here, if you had decided to move your x's to the right-hand side so that you didn't end up with negatives, you would still end up with the same answer. You'd end up with the same answer. It would still look the same. All right, cool. So thank you very much, guys.